We're going to continue to look at logarithms, but we want to look at two special types of logarithms, and these are the natural log and the common log. So what our goal here is to kind of define both of these and talk about what they are. Now, first to get us started, let's look at a problem, some problems, review a little bit of what we did in the last video. We wanted to find log base 2 of 4. And remember, we would say what that means is 2 to what power is 4? That was the question we would ask. And if one time we did the worksheet where we said, okay, what number goes in the box to equal 4? So in this case, the answer is 2. So if we have log base 2 of 8, 2 to what power is 8? That would be 3. Now if we had 2 to what power is 6? That's a little bit harder. Now we know that 6 is going to be between 2 and 3. But what's the answer? It's going to give you some decimal. 2 point something. We don't know. And there's really no way for us to figure that out by hand. We're going to need a calculator. Now, when we look at logarithms, you can have log base b of some number, we'll call it a, and this b can be any number as long as it's positive. That b can be anything, and so it's not possible for our calculator to have every single possible base built in. So there's only a couple built in. And that's what we're going to look at. What bases are built into your calculator? And there's two of them. There is the natural log, and there is the common log. So these are the two we want to look at today. We want to understand them both on the calculator, but also without the calculator as we go forward. So the first one is the natural log. Now, natural log is log base e. We talked about this e earlier when we talked about exponential functions, this 2.718. This is our natural log's base. Now, just to review, e to the x, remember we did this with our parent functions, looks like this. It has a domain of all real numbers and has a range of 0 to infinity. Now, if you remember from yesterday, when we defined logarithms, or the other video, might not have been yesterday, we said these are inverses. So our natural log, another one of our parent functions, I can draw it well, maybe not, looks something like that. And you can see, really, if I would just take this line, this green dashed line, and I would just flip this over that line. If I would just flip it to the other side, I would get natural log. They're inverses. So you can see over here, my domain for natural log is 0 to infinity, and my range is all real numbers. Now, if you think about this domain, think about it when you looked at the numbers that go in the box, and first logarithm. You can't take the log of a negative number. Not working too well here today. If I take log base 2 of negative 4, there's no way to raise 2 to a power and get a negative. I can't do it. I can't put a negative in. And actually, I can't even put in 0. I can't raise 2 to a power and get 0. So my domain is x has to be greater than 0. However, my range, I can get almost anything. Log base 2 of 1/4 is negative 2. So I can get negative numbers. I can actually have log base 4 of 1/2. The square root actually gives me a fraction. The fraction actually gives me a negative. So I can get negative 1/2. So I can get almost anything out of a logarithm. I just can't put in negative numbers. So our natural log is e, is base e. Now, we don't ever really write the base e. You will never see me write it like this. We always write it as ln of x. So, if we want to write in exponential form, ln of 4 equals m. If we write this in exponential form, it's our base, and ln is base e. E to the m is 4. Now, if we want to evaluate this in the calculator, we can actually evaluate what is natural log of 4. E to what power is 4? We don't know that. E is a decimal, 2.17, so forth. But on the calculator, we can do this. Now, if you look right down here, you can see, excuse me, the ln button, right where it's highlighted there. And that goes right to ln. If you do second that button, that's how you get there, e to the x. So ln of 4, and I hit enter, and there's my answer. 1.386. Okay. So that is natural log. It's base E. Built into our calculator. So this is one we can always do on our calculator. We don't have to try to do it in our head. The other is the common log. Common log. And this is base 10. Most of you will like this one better for the simple fact the E freaks you out. You don't like anything with the E's. You like things with just 10. It's a number you understand. But instead of putting the base 10 here, we just leave it blank. There's nothing there. This is similar to square root. If I say the square root of 4, that's 2. But if I do the cube root of 8, which is also 2, I now put this little 3 here. For the square root, we don't write it in, but really we could think of there as being a 2 there. But we never put the 2 there because with square root, we all know what it means when there's nothing there. It means 2, square root. Same thing's true with the common log. When there's nothing there, we all know, well, that means 10. We don't have to write it because we all know when nothing's there that it means 10, just like the square root. So let's look at an example. What is log of 1,000? Now what that means, if we write it in terms of our box that we did the other day, is 10 to what power is 1,000? And 10 is easy when it's like 100, 1,000, 10,000, 100,000. Just a number of zeros, right? So this is 10 cubed. So our answer is 3. So when nothing's written there, it's just log. That's the common log, base 10. ln is the natural log. Now, one thing we'll also do is, for all kind of log, we're going to look at some problems in homework here where you have to solve an equation. And most of the time, to solve an equation, what you do is you just write it in exponential form. So we're going to look at equations where we go from exponential form to logarithmic form, and all you have to do is go back and forth, and you can solve the problem. So here, write it in exponential form. It's going to be e to the 5th equals x. So in all these homework problems, all you have to do is go from logarithmic form to exponential form. Some of them you'll have to go from exponential form to logarithmic form. And then you can just easily evaluate. On this one, you can do it on a calculator. Now to get e, I'm going to go second natural log, gives me e to the fifth. I hit enter, and 148,413. So we're looking at three things here in this section. We're looking at natural log, base e. We're looking at common log, base 10. And then we're looking at solving equations. Not necessarily just with common log and natural log, but we may have an equation, e to what power, here's one of, with it, natural log again, is 12. Solve for x. Well, if we write it in logarithmic form, this is just natural log of 12 equals x. Log base e. And once again, that's just something we can do on the calculator. And so we get 2.485. So all these problems deal going with exponential to logarithmic or logarithmic to exponential. All right, next homework.